The Build Show Build Boston series is sponsored by Allura Fiber Cement Siding, Mitsubishi Electric Train US, Roseburg, Schuco USA, and Warmboard.
Climbed out over here, we got excavation going on. We still got some framing going on, but we got windows going in behind me. But I thought before we actually talk about putting the window in, let's talk about the concepts that are part of what to think about when you're putting in a window. So we left one window over here. You can see the zip tape isn't completed, and it isn't completed there because there's an actual window there, so they didn't want to waste the tape to cut it out to throw it away. But we actually have a window opening like the one behind me here set up to be cut there, but I didn't cut it in, or didn't ask them to cut it out for a very specific reason. So, you know, I had an old building scientist that said, listen, if we didn't have clients, we wouldn't have to put windows in. If we didn't put windows in, we wouldn't have problems with our wall, right? Because we could just build a wall with a weather-resistive air barrier and weather-resistive barrier, and pretty much all of our problems would go away. But we can't sell a house that looks like that. We need to sell a house that looks like that. So the minute we take that weather-resistive barrier, and you can see there, it's a fine example of continuity, one of my favorite words in building science. So the challenge is that the minute we cut that opening, we have to figure out a way to bridge the continuity from that side of the window to that side of the window and over subsequent windows. So let's jump inside. We're going to prep a bunch of these windows for window installation, and we're going to talk about our concepts and plans on how we're going to do exactly that. So let's jump inside. All right, so we jumped up here in the opening, and you can see, you know, we talked about over there maintaining that continuity, but we have to put windows in. So I'm standing in the window opening here. We typically, on a construction site, we call it the rough opening. Now, this particular project has a couple different sizes of rough openings. We have what is the rough frame rough opening, which is 1 inch larger than the width that I'm illustrating here. And the reason for that is we've added on these two 7/16 liners, jam liners, to the inside of the framed rough opening. We also have one on the top. Now, the concept behind that is, if we had the window and then we cut the opening and we want to maintain continuity, the easiest way to maintain continuity is to give me a good starting point. So I take that weather-resistive barrier and I turn the corner and I run it inside the window. Now, the window, for all intensive purposes, is part of our weather-resistive barrier system. It's also part of our water management system. It's part of our air barrier system. It's part of our vapor control layer, as well as our thermal control layer. The window assembly is one of the few pieces in a house that does all 4 control layers within its unit assembly. So, that being said, we put the window in here, but the window doesn't go tight side to side. We're actually going to install the window. There'll be a little 1/2 inch space on each side from these jam liners to the window that will fill with an expanding foam, and then we'll tape it on the outside. We'll tape the window on the inside. That maintains the weather-resistive barrier quality on the outside, but it also provides the air barrier quality. The zip R sheathing here, as well as being our weather-resistive barrier, it's also treated in my mind as the primary air barrier. So the minute I turn the corner, now I have these 2 flat surfaces that when I install the window, I can make that connection and I can get that continuity across this space. Now, one of the issues with windows and using zip R is I have the zip R, but I have this 1.5 inch of polyiso, which is a soft material, and I only have a 7/16 piece of OSB on the outside. Now, in the past, talking with builders, you know, one of the complaints is that we want to put on nice finished sills or put something around the window. We don't really have something to nail to. So how do we solve that problem? Plus, I have to provide some type of closure on the top of that foam. Now, on the sides, you can see that's easily solved for, because when I put that jam liner in, the other thing it provides is protection to that 1.5-inch foam that's on both sides of the windows, on the jambs, but also on the head of the window. So now I have to find a way to protect it on the sill and then build up the sill for a water managed installation for our window. So let's jump a window over. We got these kind of staged in next sequence. So I'll jump over there and we'll continue the conversation. All right, so we're over here in the next window opening. Got my new jacket dirty. But you can see here, we actually have a 2x8 1.5-inch that's been placed on top of that 1.5-inch of foam. Now, it does a couple things. One, it gives me a sturdy, durable platform to set these windows. Now, this window isn't that big, but even being 30 inches by 6 foot tall, this is probably a 350-pound plus window. So it isn't the lightest window on the market, but it certainly isn't the heaviest. But given that 2x8, we now have this 1.5-inch nailing face on the front. So when we want to go and attach a sill or do some type of treatment out there with trim work, we actually have something substantial that we can connect to. On top of that, we have our sloped sill, and then we have our back dam. But we're going to flash this window, so why don't we jump inside and we'll go through the steps of flashing the window. Inside, let's recap. We have a piece of sloped beveled siding there, and the reason we use bevel siding, you can see, is because it's cut with a slope already, cut into it. So by basically putting that up against the back dam, that gives us a positive drainage that will eventually flow into our water managed rain screen system behind all of our siding. So the idea of a water managed system and water management in general, understand that it has the word management in there. It's not water barrier, it's water management. So it's basically suggesting a pathway for water to get in, should it get in. Now, I've had this argument for 30 years with builders, homeowners, other architects. They say, oh, you can design a window so that windows, my windows don't leak. Well, the reality is I've remodeled, over 100 houses, and I don't think we've ever taken one apart and haven't seen some evidence of water that got into the system. So the question that you should be asking yourself about any management system is not how do I keep water out, but how does water get out? Should water get in? That's the definition of management. The other barrier system, if you want to have at it, roll the dice, be my guest. I'm into water management. So positive slope. We have a back dam. The back dam is just suggesting that we have a vertical face on the back side of that opening. And the window will get set inside of the back dam. So the idea is any water that leaks in around the window will eventually make it down into what we're going to call the sill pan. And the sill pan has that back edge where water can't get pushed to the inside. And because of the positive slope and drainage, it can only go to the outside. So that being said, we have our piece of flashing here. Now, this is also somewhat of a pet peeve of mine, because I go around and I install windows with all the builders, because a lot of them aren't familiar with the Euro-style flangeless window that we're going to be putting in here also. And I tell them, okay, well, we want to run the piece of flashing. We want to run it across the sill. We want to make sure that it comes up and engages the back dam at least about 1 inch, and that we don't get too tight on these inside corners. We want to be able to get a nice tucked fit. We want to turn up the corner about 4 inches so that our jam lining flashing will go down and lap over that properly, shingle fashion. So we're not diverting any water inside of our system, but shedding water all the time. And then the flashing has to be large enough where it can go out, go over the sill, and engage our weather-resistant barrier by 1 inch. So we're using, in this case, zip stretch tape. And you can see here, it says stretch tape on there. And the reason it's called stretch tape is because when you put it down, you'll see that we can pull it, and it's totally pliable in that we can tuck it into all of these corners and basically conform to the odd shape of the sill pan there. and then we'll be able to squeegee it out, roll it out, and get that, and then we'll continue with the flashing. But I tell most builders, I like to measure the opening, get a center mark, take the flashing, simply fold it, and gauge the paper on the back side. So that way there, I'm only really stretching out the flashing half the length of the window. A lot of the builders I work with, I tell them that, and what do? They peel it off one side, they start up here, they go down, they come across here, and they realize they're only engaging this side by an inch, or it's too tight there, or by the time you get over here, it's off angle. Again, you do it however you want. 30 years of experience has shown me that engaging the center line of the flashing and the center mark there and setting this up provides for a successful solution. See, we got the window flashed. Let's review a few things here. We talked about our back dam. You can see we have a vertical edge on this. It measures about 1/4 of an inch. We use 5/4 stock, so that's a true 1 inch back dam that went down to a piece of slope cedar that probably starts at maybe about 5/16 on the high side and goes down to about a 1/16 on the low side. So we get a substantial back dam on that side. It's set for 2 inches in the 7¼ inch rough opening, so that leaves us 5¼ to set the window on, do a finished sill, and everything we need to do on the outside there. You can see we use the stretch tape across there. The stretch tape conforms nice and neat inside the corner. We turned it up on both sides 4 inches, and then we line the jamb here. Now, the jamb liners are, again, what's my favorite word in building science? Continuity, right? It takes the continuity of the front face of the weather-resistant barrier and it connects it around the corner to the inside jamb. So conceptually, the jamb liner and the outside weather-resistant barrier are the same thing. We're just folded inward now, and we use the tape to make that connection. The same thing with the head. We folded the head in. You can see we did straight flash there, and then we just took a piece of stretch tape at the corners, which you can do as an option here too. A lot of guys don't want to fumble with a full piece of stretch tape. So what they'll do is they'll put a piece of 10-inch straight flash across the sill, and then for about 4 inches from the edge and 4 inches up, they'll turn the corners with stretch tape. And it's a little easier install. I mean, on some of these windows here that are 10 foot long, stretching out that stretch tape, it's a little bit of a circus act to get that in. But again, you can see here, we maintain that continuity on the inside by folding that weather-resistant barrier in. Now we have to get ready to install the windows. Remember my other 2 favorite words, water management. We have to give water a place to go. So if I set a window in here, and if I set the window on a flat sill, then I've created a dam or a barrier type system. Water gets in, it can't get out. So I have to provide a way for water to get out. How do I do that? Well, we used the lap siding that was sloped as part of the sill, like that. If I take the same piece and reverse it, then I've now come back and I have a level surface. But by doing that, I also provide this level of drainage underneath whatever I sit on top of that. So hence, water management, a place for water to go. If I take these out here and I simply place them on here, and you can see we just cut some strips of flashing tape. I engaged the top of the back dam, went down the face, across our shim, and then just simply taped it off. So those have nowhere to go. I left this one off so you can see what we were doing. But in a window this size, I went with 4 of them. I like to get these on somewhere around 12, 14-inch centers. The other thing that's important is the one that goes in the corner, you don't want to push that up tight against the corner. Why? Because if I push it up tight against the corner, there's no place for water to go. Water management system. I know I'm repeating this 100 times in this video, but for 10 years I worked with a company where we traveled around the country And most of our investigations were water management investigations. Why? Because people didn't give water a place to go. It's the #1 litigation in the country in terms of construction, water damage. So we have to treat water with the highest respect, give it a place to go. So the shim, I like to place it about 3/4 of an inch out of the corner. Any water that gets into my system, which it will then flow down, get into my sill pan. The positive slope will allow it to drain into my rain screen system. Now, one of the misconceptions that people have is when I talk about the amount of water that gets in, we're probably talking about teaspoons of water in a ratio to gallons of rain, right? So it's not like we get 1 inch of rain there and water is just simply pouring in here. Now, in some cases it might if we didn't have overhangs and all of that, but understand that we have our window head here and it's 14 inches, maybe about 12 inches below a 22-inch overhang. So the ratio there is 2 to 1, which is a very respectable position to put the head of a window in, right? I try for 1 to 1 at a minimum. 2 to 1 is aggressively much better, right? And years ago, I was on a project where we traveled around the country and we did nothing but test window installations and flashings. And what we came to understand is that most window leaks actually happen at the head casing or the top of a window, especially in 2-story walls because they're the ones that are the most unprotected. Here, 1-story building, heavily protected. A lot of this is insurance, but our biggest piece of insurance is I put a 24-inch umbrella on the house. So, recapping, water comes down. Our windows are simply going to sit on these 4 shims here that are equally placed. There'll be a space for water to migrate underneath. We'll seal the window on the inside. We'll seal the window on the outside except for the sill. And we'll press on with the windows. So we'll get the windows here shortly. We'll grab them. We'll start putting some in. Well, there you have it. We got windows prepped. We walked through all the steps. We need windows. Bright and early tomorrow morning. Join us. We're getting in the truck. We're driving south. Schuco USA. They're fabricating our windows down there. We're going to check in on them. And then real soon, those windows are going to get trucked up here and we're going to be putting in windows. So stay tuned. We've arrived. Steve Basic Architect, Build Show Build Boston. We're down at the Schuco factory. We're going to go see our windows for the project get fabricated literally on the other side of the wall. Let's get going. We're starting here. You can see behind me, this is where all of the material comes in to the fabrication plant. Now, not all of that is for Schuco USA. They also run a distribution out of here for Schuco components. But I think it's also really important for you to understand that Schuco is kind of, it's a component manufacturer. They're not a window manufacturer. They make parts for windows, they make components right down to proprietary screws that connect the pieces. They also sell the machinery you're going to see today to fabricators. That's all Schuco proprietary machinery. So when you're dealing with Schuco, you're basically getting the whole package of a Schuco window, and it's coming out the back end, and we call it a Schuco window, but the truth is Schuco USA is the only fabricator in the world that actually has Schuco in their name. So anyways, we got all that product. No need to stand here and look at it. Let's go see how we put windows and doors together. As you can see behind me, we have a number of different machines. That raw material comes in, it gets placed on a rack per project, and then we have these various machines. And again, you can see the Schuco tag. These are machines that are brought here from Schuco. So these are Schuco machines. The raw material gets here. These 3 machines are solely dedicated to just cutting these components to the length, putting the miter cuts on there, and getting them set up. Now, after every piece gets cut, it also gets tagged. So this is kind of the start of where windows and doors get put together, because here pieces become personalized. And speaking about personalized pieces, we have these pieces right here. So this one here is actually the frame for the front door at Build Show Build Boston. So you can see the raw components are here. This is going to get cut into the lengths that we need it to be cut, the necessary miter cuts and such, and then it'll get fabricated down the line into what we know as the door. So you can see here, they control all of their waste. They recycle when they can. Here's some pieces that are cut. You know, these have been cut for that proper miter cut. You can see this one here actually has a black frame on the outside and a white frame on the inside with the thermally broken material in the middle. And the minute it gets cut, it gets that project tag attached to it. So as these racks go down the line, this can be a whole window package. As we move down here, the components simply get more involved in drilling, cutting, hole making, etc. So once they're cut the length, those racks come down here, and then these racks are put on a CNC machine. So the CNC machine and everything here is done on computer so that they can control the quality of where those cuts are being made and the precision in which they're made. Nothing here is measured in inches or feet or yards. Everything here is measured in millimeter, even the longest of lengths, because that's the accuracy and the tolerance that they're being built to. If I grab one of these pieces off the rack, you can see that this one was cut to length down there, but once it comes up here to the CNC, now we have holes for the screws for fabrication. The weep holes have been cut in, and you know, a couple pin marks have been made there for alignment purposes and ejection purposes for the sealant. But the process just constantly continues as we move down the line. So let's go check out and see how some of these are actually getting put together. All right, so we're over here. They had a really fancy name for it. I'm calling it the crimping machine, because basically what it does is, you can see in the drawing here, there's 4 components to this profile. There's this base component here, there's the isolator component on this side, there's another wall component there, and then there's the finished component on the inside. So it's 4 components, and you can see they all have these little channels where things fit in. But it's not like you could just grab it and snap it in. You have these 4 pieces here. You can see it's there, the isolator, and then that front piece. But these need to run through this crimping machine, and basically what it does is it takes those 4 pieces and presses them together and crimps them together at all of these joints. So basically these 4 pieces become one. So they're gonna give us a quick demo. Let's take a look here. So one of the real cool things about the crimping machine is not only does it crimp it, but then it applies protection to both sides of the material as it goes through the machine. So it comes out on this side, 2 key things. 1, it's fully protected now with the Schuco tape, but 2, it went into the machine as 4 part numbers. It comes out as 1 component number. So things are changing not only in what the material is happening, but the way that Schuco USA organizes all the components for the windows. So now we just either have a sill or jamb or head to a window or door. We don't have those 4 extrusions anymore. They cease to exist. So let's get going. There's so much to see here. All right, so we're over here. I got my good buddy Lance. We have one of their fabrication tables. This is actually one of the windows that we're going to be putting in the project. This is one of the client's windows. It's one of those 4 that we did the prep on, which is really cool to kind of see the whole thing shaken out here. You can see we have our jamb components. We have our sill or head component here. We have our reinforced corners. Those get slid in here, and then they're going to get screwed and attached. But my understanding, Lance, is that the Schuco actually makes the miter adhesive sealant, and that's where the strength of that corner comes from. It's not the fact that they're mechanically fastened, it's the fact that this proprietary sealant adhesive that gets put on the miter is what actually holds the window together. Now, why is that important? Well, if the window did flex in any way, the structural integrity is managed by a flexible material, not a rigid mechanical fastener, right? So it allows a little bit of movement in the window without challenging any of its structural integrity. So, Lance, let's have at it, buddy. Let's see what you do, my friend.
I'm going to apply the miter seal at the corners of the...
One of the greatest things about manufacturing is, as high-tech as that sealant is, it's a piece of cardboard that puts it on. Just so cool. And Lance, I'm guessing that I wouldn't be able to pull this apart when you're done.
No, you can't.
No. Lance, how long you been working at Schuco USA?
3 years now.
3 years. And you're their master window fitter, right?
Well, I'm trying.
You're trying.
I'm trying to get with my buddies the same way like me.
There you go.
Yeah.
So those get put in, but they still get a mechanical fastener, and I have one here in my hand. It's basically a little pin that you can see. It has a space there. So as it gets driven in, it gets compressed based on that little slot in there. And the expansion of that pin, or its attempt to expand, is basically what's holding that corner together until the adhesive sets up and makes that a joint that is extremely successful. So have at it, my friend. You know, one of the beauties of what you do, Lance, literally thousands of people over the course of the lifetime of this window are going to walk by and say, man, that's a beautiful window. Never knowing that Lance was the guy that put it together.
Well, that's how it is.
But your mastery is going to just provide enjoyment like you wouldn't believe. And if you can't tell, Lance, I'm pretty excited just seeing this thing get put together here myself. If we can zoom in here, because the precision of that window frame, you know, we're getting German engineering, Schuco, being fabricated in America, and we are just getting extremely beautiful work done here, and it's being done here in the United States by Schuco USA. Just a fabulous job. We got great people like Lance putting these things together. And Lance, you're going to put in a two-part epoxy where, yes, the sealant does hold it, but ultimately the strength of this frame going together is the epoxy that he's basically going to inject, and it's going to expand inside the frame and basically hold that frame together for the life of the window. So have at it, my friend. And you can see the CNC, it actually drilled these injection holes in it down there at the station that we just visited. And Lance, how do we know that you put enough in?
Then it's going to start coming through the nail holes, and then you know that it's fit.
So there's some fill holes there that when you start seeing it ooze out, we know Lance's job is done.
Yes. See it start oozing out right here and there.
Right.
You know that it's fit.
And the beauty of using that kind of fluid applied fastening system ensures that we're pretty much getting in every nook and cranny in that corner and engaging it and holding it together.
Because it fills up that cavity, it can fill up the teeth in the corner clean.
Fills up that cavity. Well, Lance, I got to tell you, man, beautiful job. Keep up the good work. If you don't mind, any of the ones that have that project number, give it a little extra oomph. It's our personal project there, so you're doing a great job, buddy. Thank you.
Man. Appreciate it.
All righty. You saw the frames get put together. Well, we're over here. We have one of the sashes. So over here, all of the weather stripping and hardware gets applied to all of the non-fixed windows. So they have their protective racks here. We drop the sash on. This isn't the window frame, this is the window sash. The difference is the sash is the piece that operates inside of the window frame, right? So this thing gets heavily gasketed as well as the window frame. So the first piece of gasketing that we put on, my good friend Tony here, I just met at Schuco USA, we're putting on, it's called a rebate gasket, right?
Yep.
Neither one of us knows why it's called the rebate gasket, but it's called the rebate gasket. And you can see there's a little channel here that is made in the actual original component there. And then this basically just snaps in, right, Tony?
Yep.
So Tony's an expert at this. We were going to have a race. I chose not to embarrass him today. But Tony, show us how, buddy. You're a pro at this. So that's just pressure fit, right, Tony?
Sure.
There's no glue, adhesive, no mechanical fastening. It's just...
We'll glue right at the end right here.
Gotcha.
Together.
To hold that together when we're done here.
Yep.
All right. But this has, you can see the gasket, it just has that little piece that compresses and basically gets pressured into that little groove, expands on the other side, and hooks it so we can't really pull that out. So I know I might be beating a dead horse here, but one of the things that I just find incredibly amazing as I walk around here, watch the windows, everything here is proprietary to Schuco. When you say you're buying a Schuco window, I mean, short of the glass, everything is a Schuco product, down to the glue that gets used to miter the rebate bead and as it gets pressed in. So, you know, they take responsibility for the engineering of the whole system, not just a small part of it, not additive parts, but the whole system, which is just incredibly commendable. So Tony's going around, and now after the rebate, we're putting in the hardware. So this is basically the gearbox that will get installed when we turn the handle and we get the tilt function or turn function. Well, all of that is happening inside this gearbox. It's being translated via a strap that gets into these corner hardware pieces where you can see that's where the pin is, and then those pins engage into the frame, and that's basically what provides that exceptional Euro seal that makes these, you know, passive house quality airtightness on these window frames. So, Tony, don't let me stop you, man. Have at it. And as you can see, because all of the hardware and everything is proprietary to the Schuco system, it basically just snaps in all of these pre-molded, extruded grooves inside the frame. So pretty amazing system. All right, so I'm holding what's called a locking bar in my hand. Tony's putting in one right there. You can see the locking bar basically makes the connection between the gearbox and the corner pieces of hardware here that has those pins engaged. Now, the interesting thing that's happening here is this gets engaged or installed here, and when the gearbox gets engaged, it engages around the corner. So all the pins on all four corners are being engaged, even though it's all being initialized here. These locking bars pretty much become that strap or that extension that brings that corner to life when you engage that gearbox. Just fascinating technology. All right, so we flipped the frame over. Now we're going to install another gasket, and you can see this was the gasket that we put in on where the frame and the sash meet. This is actually where the glazing IGU is going to meet the sash. And so it's also a rebate gasket, but this one's called the glazing rebate gasket. And you can see just the size of it. It's a far more formidable opponent to airtightness, water management, etc. But that's basically what's keeping air and water out in the space between the window sash and the IGU. Now, Schuco actually makes proprietary tools. As Tony installs this and you come to the corner, there's a machine here that actually cuts a V groove into it, and you can see the V groove there. But the whole reason for the V groove is so that now we can get a continuous installation of that rebate gasket around the corners. So just Schuco has definitely thought of everything. All right, so we have the sash, we have our rebate weather stripping, our glazing rebate weather stripping. Now, one of the things that I just learned is that in between the sash and the IGU, and the IGU is basically insulated glazing unit. That's where our 3 panes of glass are sealed around the perimeter with the argon gas inside of them. And then that gets installed in the sash as one unit. But understand that between the IGU and the sash frame, there's an airspace or a little bit of a space in there. So Tony just went around and he installed what we call the glazing insulation around the whole frame. But notice that in a couple places, he's interrupted it with these glazing blocks. Now, what the glazing blocks are doing is those are permanently fixing the location of the IGU inside of the sash frame. Because if we just relied on the insulation, that IGU would be able to have some micro movement inside the sash frame. By putting in these hardline blocks, that ensures that the IGU stays in the place that it's put in when it gets set inside this sash. Now, why is that important? Well, if we just let the IGU run willy-nilly, well, it's going to settle towards the bottom and sit on the insulation. Or as you open the window, it's going to want to move across that window. So this really fixes the placement of the IGU, and that's what provides that nice perfect balance every time you open up that window. So we're getting ready now to put in what's called the glazing bead, and that's what is actually going to set the window IGU against. I'm going to introduce another new friend of mine, Everett, and Everett's bringing over, yes, the Funk module, right? Yes. So the Funk module, Everett, this is just a very precise measuring instrument that we're going to apply here. But the understanding is that the Funk module also has all of the glazing bead characteristics already inputted into this.
Yes, because there's a lot of different type of glazing beads. There's some smaller, there's some thicker, so we push the numbers in, and then the saw automatically recognizes.
So then you put in those parameters. We actually measure this with the Funk module, and all of that information goes right over there to the cutter. So you go through your series of start buttons, and out comes a very precisely cut glazing bead.
Correct. And you always
perfect every time.
Perfect.
You never fail.
99.9%.
That's what I like to hear. Well, have at it. Show us what we're doing here, buddy.
Last one. Then I press it twice at the end.
And that acknowledges that we're ready to cut.
Right, we're ready to cut.
And I just want to point out, if I didn't mention it earlier, this is actually one of the client windows. So this is the anthracite gray. This one here is going to be going in the plant room. Hopefully I remember when we're installing the window, I'll say, hey, remember when we had that out there with my good friends Tony and Everett, and we were putting that glazing bead and everything together. But yeah, this one's going to be out there at the Build Show Build Boston. Let's go see some glazing bead get cut. All right, so hot off the glazing bead cutter, you applied some clips here for installation. Again, all of these grooves marry up with grooves on the sash frame. So I'll hand that to you, Tony, and you can show us the fine work that Everett did. So there you go, folks. All right, Tony. So we started with our sash. We got our rebate bead. We got our glazing rebate bead. We got insulation. We got the pads for the glazing. And now we have our glazing stops in here. That means your work is done. We send it over to glazing. Let's get some glass. Thanks, buddy.
All right, thanks.
All right, so we're over here at the glazing section. You know, all these tables are the frames and sashes, everything's getting married up and put together. You can see we actually have some of Scott and Jonathan's windows already fabricated, packaged up. You can see the protection is on the corners there. It gets tightly wrapped. They're getting ready to get shipped as we come down. These are all Build, Show, Build Boston windows that we're going to be seeing in a very short time going in the walls. Down here, you can see this is where they prep the IGUs. So they come in on the racks. The logistics ensures here at Schuco USA that the glazing comes in as it's needed. So you're not getting a piece of glass that doesn't have a frame that's sitting on the rack there. So it's heavily coordinated logistically to ensure that the right glass is here on the table getting cleaned for a frame that's down the way there. So you can see that all comes in and gets installed, gets packaged up, and then here we have our crate. And this crate has a finished window. The next time we see that window, we're going to be out at Build, Show, Build Boston, lifting that one up and putting it in the opening. But before we leave, we have to see this piece of IGU get installed in the frame. So they're about ready for us. Let's go check this out and wrap it up. Before we go check out the IGU, I just wanted to talk to you a little bit about a really cool technology that happens out here. So the windows get made, well, every one of the windows then gets a tag. And you can see here, this one has been tagged here. And there's a phone app that you can come up, you can scan that tag, and it basically records all of the information about this window. When it was made, where it was made, all of the checks that it went through in quality control, all of the pertinent sizes and metrics of this window. So the reality is 10 years from now, if you have a problem with a window, they could just scan this with the app and the Schuco USA factory will know everything that they need to know about that window because it's embedded on the window on that tag. Just really cool technology that we're moving into, that as the window leaves the factory, it leaves with all of the information that was developed here at Schuco USA. So now let's go look at an IGU getting installed. All right, so you can see the IGU got brought in via crane. Nothing gets carried. Nothing's at risk of people getting hurt. My good friend Adilio is here. We're actually going to be putting in these silicone spacing blocks, and these basically fix the window in the position inside the frame. Is that correct?
Yes.
That's what we're doing. So this is just a little wedge type tool to allow us to get these in there?
Yep.
Have at it, my friend. So that just slides down in, and as we go around the window, you'll put those in, and it'll basically fix the location of the glass inside that frame. So this just distorts the frame enough to get you to drop that in. Gotcha. We just saw Adilio. He put in the spacers. We fixed the IGU, and then the final two steps are we put another glazing bead in here. If you remember my good friend Everett, he cuts those precise. They snap in, and then we finish with one last gasket, which basically seals the glazing bead to the face of the glass, and voila, we have windows completed. So these are ready to get shipped. We have a crate over there. We're going to put these up on the crate. The next time we see these, we're going to be out at Build, Show, Build Boston taking them off the truck. All right, so one of the really cool things about being out here at Schuco USA is not only are they fabricating the windows, but they do a lot of their own quality control on the assembled units. So we're over at their spray rack section where they have a contract with this particular client where 3% of the windows are going to get tested. It's a waterfront property. The client wants to be ensured that the quality of the assemblies are being met. So they're getting properly tested here with a spray rack. So you can see we're all set to go back there. So let's unleash some water. All right, so you saw on the other side of the wall there, our window's getting fabricated. I thought we'd jump in here. This is their training center here at Schuco USA. And we have actually an installed little window here, 30-inch square window. I thought it'd be really good to just go through some of the pieces of the window before we get out to the job site and see these get installed. So you can see here, this is an unfinished frame here. So usually they get sent out and they get powder coated or finished in some kind of color or stain or whatever they use for the applicable finish there. But we have basically an unfinished piece here. Kind of looks like stainless steel, but it isn't stainless steel. But we have the frame here. We have the sash, which is the operable part in the frame. If we have a fixed window, obviously we just have the frame with the glazing in it. We have the little caps here, and these are just snap-in caps that go on the weep holes that we saw getting cut out there. So that's our water management system. But I really wanted to talk about the operation of these windows. So you can see, typically they have a lever type handle. If I rotate it up 90 degrees and pull the window, that is the turn option. And you can see here's all of the things that we saw out on the fabrication floor, the gearbox, all of the corner slides and how it engages, our little rebate gasket there happening. If I close the window and rotate it another 90 degrees, that engages the tilt option on the window. Now, the important thing about the tilt option is we still get the proper ventilation, but notice that it's shedding water down into the trough. And if we open this up, we'll be able to see it. The trough down here that is directly attached to those weep holes. So in the tilt function, should I forget to close my windows and it rains, all that water just sheds down, drips into the trough, drips out the weep holes. So the whole window assembly is a self-water managed system. Locking it draws it against all those beautiful gaskets that we had installed. The other thing of note is, notice that there's a space around the window frame. When we install these windows, we're going to go through all the little tidbits of how we attach these anchors, how they get attached to the wall system, but understand that the window is basically suspended in the opening. These are flangeless European windows in style here, so we have that space that will then be able to air seal. They're of really good performance, and it just so happens that Schuco USA, we have one of their high-tech guys here. He's going to come and spend a little bit of time with us. His name is Spencer. Come on, join us, Spencer. And so Spencer just flew in from Seattle just for today to come out and have a good chat with us. But Spencer's going to talk about a lot of things about the performance. But before I turn it over to him, like the very first passive houses that I have done like 10, 12 years ago, Spencer worked for the window distributor. And so we're long-time friends here, and catching up with them has been a great thing. But Spencer, not only do those windows look good and operate good, they perform very well.
Yeah, that's right. And what's really important with a passive house project are two fundamental criteria. First is airtightness, and second is thermal performance. Now, with the Schuco window, the way we accomplish the thermal performance is in the construction of our frames. So as you have seen in the production of the window, we have a thermal bar that separates the inside and the outside aluminum sections. Now, the U value of the frame for this particular system is set. And what that means is that we have a standard performance depending on the thickness of the frame. For our passive house window, you're looking at about an R6 or an R7 frame section. And then when you look at incorporating the glass, you actually achieve an overall U value that's a combination of the frame and the glass together. Now, this U value or R value is going to depend on the size and configuration of the window. When we talk about window performance, we usually talk about NFRC ratings. So for an NFRC size window with the type of glass that we're using on your project, which is about an R9 glass, we're really looking at an overall R6, R7, depending on the configuration of the window, size of the frame, size of the
And that
glass.
R6, R7, just to be clear, that's normalizing the values of the frame, which are the worst part of the window,
Correct.
and against the center of glass, which is the best part of the window.
That's right. So typically your glass is always going to be a higher performing thermal value than your frame. And what we're doing with these thicker frames is we're mitigating those frame losses by adding more insulation in between those sections of aluminum.
Right.
So when it comes to airtightness, these windows have a couple of features that are really critical for Passive House. The first is the center gasket. So the sash closes on the center gasket, and when we lock it into position, we're actually squeezing that gasket shut, so we're getting a really nice airtight seal all along the perimeter. Because our hinges are concealed, we don't have any interruption of that center gasket, so we get nice, good air sealing all the way around.
And one thing that I've learned about Passive House is that's really important, which also drives my decision to use windows like this. When you do Passive House airtightness testing, it's positive and negative test, and it's the average of those.
That's right.
Right? So that if you had a bad performer, say, that was pulling away from the frame in a negative pressure test, it would be a horrible window. So your window has to perform exceptionally well pushing the window against the gasket, but it has to perform equally as well when I'm trying to pull the sash away from the gasket.
That's right. And as I mentioned with the hardware, we're actually using these keepers and the locking points to compress that center gasket. But the other gasket that's also really important is between the glass and the frame. So in a non-operable or in a fixed light, what we're relying on are the gaskets that are used when the glass is installed into the frame. And at the corners of the glazing beads, we have additional foam seals that we put in just for the airtightness. And this is really important for Passive House air performance.
Right. And one of the things that I've learned in dealing with these windows is that from a performance perspective and a price perspective, glass is cheap, frames are expensive. Mm-hmm. And glass is good, frames are bad. So the bigger the window that I make, the better performer I get, the cheaper the square foot cost. Now, obviously the unit cost goes up. If I triple the size of the window, the unit cost goes up, but the cost per square foot goes down in that window because glass is cheap, frames are expensive.
That's correct.
So, one of the things that in a lot of my Passive House projects that you'll see is you don't see a whole lot of 2x2s, you see 12 footers by 6 footers. Because I'll take that idea of those 3 or 4 windows and gang it up, because that one window is now 60% of the cost of 4 individual windows.
That's right. And the fewer frame sections you have dividing the glass, the fewer edges you have for potential air losses, the fewer thermal bridges you have. So bigger lights of glass are generally always better economically and for performance.
Right. So, I don't know. Any last words?
That's it.
Schuco USA. We're down here. Now, keep in mind, this is part 1 of 2 parts on windows. We have so much information about windows. We love these so much, so many good talking points that we're actually going to break it into 2 parts. So we have the window frame prep. We have our little tour here that we took of the factory today down at Schuco USA. But part 2, that truck is going to arrive. We're going to unload the windows and we're going to get them in those rough openings. And we're going to put some windows in the house. So until we get back to the job site, Steve Bazek Architect out here at Schuco USA.